Hello everyone, this is Mrs. Snook with section 2.6, which is about rational functions. And what we're going to do today is we're going to identify the vertical and the horizontal asymptotes of a rational function. And we're going to identify wholes and intercepts, both x-intercept and y-intercept. And this information that we are gathering from these functions, we're going to use those in section 2.7 to sketch graphs of the functions. So first up, what is a rational function? Well, in short, it's a function that can be written like a fraction, where you might have a polynomial in the numerator and another one in the denominator. And here's an example, x minus 7 over x plus 2. That's a rational function. Same thing with 7 over x squared minus 15. Next up is what is an asymptote? Well, an asymptote is a line that a graph approaches as x or y increases. So it gets closer and closer. It doesn't necessarily cross it. In vertical asymptote, like this one here in red, to find that one, you're going to set your denominator equal to 0. Horizontal asymptotes, a little bit more challenging. You have to look at your numerator and denominator and compare their degree. And then using this chart right here, you can then determine where your horizontal asymptotes are. So if your numerator is of a smaller degree than the denominator, you're going to have an asymptote at y equals 0. That's also known as the x-axis. If your numerator is larger in degree than the denominator, you have no horizontal asymptotes at all. What if they're the same? Well, if the degree is the same, then you're going to take the leading coefficient of the numerator and the leading coefficient of your denominator. In this case, we have an invisible 1. You're going to do 2 over 1. So take those coefficients, put them in a fraction, and then you will have a horizontal asymptote at the line y equals 2 in this case. So let's do some examples with this. We're going to find the vertical and the horizontal asymptotes for the graph of each of these rational functions. So the first thing you need to do is factor, because that's going to help us find where our denominator equals 0. So I have 4x over x times x squared minus 4. That equals 4x over x times x minus 2 times x plus 2. So that means we're going to have vertical asymptotes at x equals 0, x equals 2, and x equals negative 2. Now for your horizontal asymptotes, compare the degree of your numerator to the degree of the denominator. And in this case, my degree of the numerator equals 1, denominator equals 3. So we have our numerator has a smaller degree than the denominator. So this means we have a horizontal asymptote at y equals 0. All right, next one. Again, factor everything that you can. We don't really need to worry about factoring the numerator for this one, so we'll just leave the numerator as it is, although it is factorable. X plus, oh, wait a minute, look at that. Be careful. I want to rearrange. All right, so we are going to have to factor the denominator. And you see we have a leading coefficient of 2. So we're going to have to do slip and slide. I'm going to come over here to the side, and I'm going to factor the denominator. So 2x squared plus x minus 15. I'm going to slip that too. So I get x squared plus x minus 30. X plus 6, x minus 5. Now slide and then divide. X plus 3. Bottoms up on this one, 2x minus 5. All right, so now I have 4x squared minus 100 over x plus 3 and 2x minus 5. So my vertical asymptotes for this one are at x equals negative 3 and x equals 5 over 2. Horizontal asymptotes, we'll compare the degree of your numerator with the degree of your denominator. They're both the same. So now take your leading coefficients, and it's going to be y equals 4 over 2, so y equals 2. That's where your horizontal asymptote is. Last one. I want you to notice that the x plus 1 in both numerator and denominator, those cancel out. So my equivalent expression is just y equals x. So because they cancel out, we don't actually have a vertical asymptote at x plus 1. Instead, we have something else. I'm going to explain that in just a moment. So our vertical asymptote for this one is going to be none. And I'm going to put a little star next to that because we're going to talk about that in a moment. And then our horizontal asymptotes, well, the degree of my numerator was 2 because x times x is x squared. The degree of my denominator is only 1. So that means I don't have any horizontal asymptotes either. So now let's talk about what happens if we can cancel out our denominator. So what happens then is called a hole. And what that means is you have a discontinuity there. So for example, in this one we have x plus 3 times x plus 2 over x plus 2. Those cancel out, but you're still not allowed in the domain to have x equals negative 2. My equivalent expression is just x plus 3, but in our domain, x cannot equal negative 2 because originally that would have made your denominator equal to 0. So we call that, because it cancels, we call that a removable discontinuity, and it makes a hole. And the hole will happen at the x coordinate of negative 2. And then you can plug in your negative 2 into the expression and figure out what the y is. So y would be negative 2 plus 3 equals 1. So on your graph at the point negative 2, 1, you would place a hole. And what that's going to look like is something like this. So there's your line. And then at negative 2, we're going to have a hole. And that just looks like a little circle put in there. We'll do more of that next time. Now, if it cannot cancel out, it's called a non-removable discontinuity, and that's a vertical asymptote, which is what we've been doing. Now, your x-intercepts, that's where it crosses the x-axis, set your numerator equal to 0. So whatever's upstairs equals 0. That goes for your x-intercepts. And that's also called a 0. And then the y-intercepts, that's where your x equals 0. So wherever x equals 0, and therefore your graph crosses the y-axis. Okay, so let's do some examples where we're going to find all of these: vertical asymptotes, horizontal asymptotes, holes, x-intercept, and y-intercept. Step 1, factor your denominator. All right, step 2, factor numerator, but there's nothing to factor here because that's just a 1. So I'm going to have vertical asymptotes, set my denominator equal to 0, so x plus 4 equals 0. That gives me x equals negative 4. X minus 4 equals 0. That gives me x equals 4. So my vertical asymptotes are at x equals negative 4 and x equals 4. Horizontal asymptotes, inspect the degree. My numerator has a smaller degree than denominator. So my horizontal asymptote is at y equals 0. Holes, nothing cancels, so there are no holes. X-intercept, that's where your numerator equals 0. My numerator is 1. It can never equal 0, so there is no x-intercept on this graph. Y-intercept, just plug in a 0 for the x. So for my y-intercept, I have y equals 1 over 0 squared minus 16 equals negative 1 over 16. Okay, here's another one. Step 1, factor denominator, 3 times x plus 1. Step 2, factor numerator, x plus 1, x minus 1. Let's see what cancels. Those cancel out. So my equivalent expression is x minus 1 over 3. And we are not allowed for x to equal negative 1. So vertical asymptotes, none, because my expression with the x canceled out of the denominator. Horizontal asymptotes, I have a second degree over a first degree, so none. Holes, well, I do have a hole at x equals negative 1. So let's plug in the negative 1 and get the y-coordinate for that. So negative 1 minus 1 over 3, I get negative 2 over 3. So negative 2/3 is your y-coordinate. X-intercept, so what you're going to do is set the numerator equal to 0. X squared minus 1 equals 0. Better yet, let's use our equivalent expression. We have just x minus 1. So for there, x equals 1. So I have an x-intercept at x is 1, y is 0. I do not have an x-intercept at negative 1 because I have a hole there. And then y-intercept, just set your x is equal to 0. And our y-intercept is at 0, negative 1/3. Okay. Here's another one. Step 1, factor x plus 2 times x plus 1 over x plus 1. What cancels? So my equivalent expression is 1 over x plus 2. Vertical asymptotes. I have 1 at x equals negative 2. Horizontal asymptotes. Y equals 0 because my degree of the numerator is 1 and denominator is 2. Holes. I do have a hole at x equals negative 1. So plug in a negative 1. So negative 1, 1, you'd have a hole on your graph. X-intercept. Set your numerator equal to 0, but that cancels out because we have a hole there. So using our equivalent expression, 1 over x plus 2, that numerator is never going to equal 0. So we don't have an x-intercept. Y-intercept, just plug in 0 for your x's. So we have a y-intercept at 1/2, 0. All right, let's just do this last one. First thing you want to do is factor everywhere. So I'm going to pull out an x, and I have x squared minus x minus 6. Pull a -1 out of the denominator. Let's make it a negative x. Pull that out, then I get x squared plus x minus 12. Let's keep factoring. So I have an x times x minus 3, x plus 2. I have a negative x in my denominator times x plus 4, x minus 3. Now let's see what cancels. Well, that cancels, and that cancels. So my equivalent expression is x plus 2 over x plus 4. Don't forget your negative in front. All right, vertical asymptotes. Well, I have one at x equals -4. Horizontal asymptotes, numerator and denominator were both third degree. So I do 1 over -1. So I have a horizontal asymptote at y equals -1. Wholes, my x minus 3 canceled out. So plug in a 3. I have a -3 plus 2 over 3 plus 4, -5 over 7. So I have a whole at 3 and -5/7. X-intercept, where does your numerator equal 0? X plus 2 equals 0, x equals -2. So I have an x-intercept at -2, 0. Y-intercept, just plug in zeros for your x's. And I get a -0 plus 2 over 0 plus 4. I get a -1/2. All right, that's it for today's lesson. Thank you for watching and have a great day.